The last one, when I poured the solid out, it kept its shape. Why? Because solid molecules, yes? Yes, but the question is why does it keep its shape? I'm going to call on three different, but only about.
Because it's hard.
Because it's hard. Okay, what do you do?
The hard object is stuck together.
Stuck together, right. The molecules are stuck together. They can't move. Okay, any questions? Okay.
I'm just going to say that it was that the reason why they can't take the shape of the shape.
Right, and we said before, it needs force to change the shape of a solid, right? So without the force, the molecules are stuck together. Now, but there are three different kinds of solids. Solids that are brittle, where the molecules are stuck together like glue, and the only way to get them to move, what would happen if these are all glued together, what would happen if I moved these molecules? Break, that's the word I'm looking for, it would break. But if we have an elastic solid like rubber band, or a balloon or something, the bonds are elastic. And so you can stretch the bonds of a rubber or an elastic solid, and they come right back to the way they were before. You stretch a rubber band, it goes right exactly back to the way it was before. Right? The last kind is a ductile solid. Right? A ductile solid is like a ball of clay, and if you put pressure on that, it changes shape. Does it go back to its original shape? No, it stays smushed. Well, what's happening there? The molecules in there are all held together, but they're held together almost like magnets. You can take a magnet and it's stuck to something and you can move it and slide it around, right? So if this was a bunch of molecules that are stuck like magnets, you can move them around on each other, but they all stay still as a solid together, but they can change shape and stay, if they squish it down, it stays squished. If they squish it up, it stays up, right? So that's how a ductile solid works. Your question?
I know another word for magnetism.
Magnetism, that's right. Magnetism is the force that pulls the magnet. Okay, so that's the different kinds of solids. All right. So now, if we move over to liquids. Oh yeah, the experiment. Okay, so I need a volunteer. Anybody? Nobody wants to do it? Okay, who are we going to get?
We'll wait in the back.
In the back? Yeah, sure. In the back?
In the back?
The white shirt, yes.
Yeah, I can't.
The materials we just talked about. So here is an elastic solid. I want you to take that elastic solid. I want you to hit it with a hammer.
Oh my God.
Now, okay, before you hit it, now move your hand away. Before he hits it, anybody tell me what's going to happen?
It's going to crack and it might. I want to break the table.
Don't break the table. Hit the ball, not the table. Yeah.
It's going to bounce.
It's going to bounce. Okay, yep. See that? Because it's elastic, nothing really happens to it. It squishes down a little bit and it comes. Okay, stop. It's going to come right back to its original shape. If we have a ductile ball, now what's going to happen when he hits it? Yes. It's going to smush that thing really good. Oh yeah, I mean, hit it.
Hit it, boy.
There you go. That is one flat ductile solid. Okay. Now we have a brittle solid. Atomic fireball. What do you guys think is going to happen when we hit the brittle solid? I can't hear the answer.
It's going to break.
It's going to break. Smash that.
Oh.
Yeah, let's get another one. Let's hit it right in the middle. Hold that hammer a little farther back. You want to leverage? No. All right, hold the hammer a little farther back and smash. Did you notice which caused you to move farther back? Smart. Okay.
Good job.
All right, good job. Thank you very much for your help. Okay, I'll take your hand here and the hammer there. My potion is almost ready. It's free.
your other one?
What is it? A tamale? What?
Well, we're trying to Mr. Hyde.
Mr.
Okay. There we go. Professor Smarty Pants. Okay. So solids. Now we're going to move on to what's this stuff? Liquid. And I'm going to need another volunteer. It's really tall.
Scarlet.
Who has permission?
I'm taller than Marie.
Okay.
I'm taller than
What I
Mary.
need you to do, Sarah, side to please here. Okay. I'm going to fill up one side of the contraption, or in French, la contraction. It's not right. I don't speak French. Okay.
He speaks science.
I speak Spanish. So I'm going to fill one side
Spanish, science.
of the contraption
I speak Milan. I speak English.
with the purple water. Okay?
I like
And I would like our volunteer to please put the palm of your hand, and try not to pull on but put the palm of your hand on top of there and make a good seal with your palm. Okay? Now guys, I'm going to open this valve. And who can tell me what's going to happen? Yes.
The water's gonna go up.
The water's going to go up. Her hand has magical suction power.
Oh my gosh, this
Yes.
Maybe he's gonna go up and get her hand and go down.
Wait, nothing happened. Why didn't anything happen?
Because her hand is up.
But why did nothing happen? Because her hand is not going.
The air needs to go.
Air needs to go. Wait, but he answered without his hand up. So
The air needs to push the water down, and there's no air pushing the water.
Exactly, because she's not letting the air in. So take your hand off. Let's see what
Who
happens.
answered that?
The blue shirt. Cool. Okay, now I'm going to put more water in here so all of you can see it. But I want you to notice something that's going to happen to the water. Okay? Okay, let's let it go to a stop. And what do you guys notice is interesting about this water? You? Yes. Right, and then what happens to it when it stops? Okay, I'm sorry, what you?
Liquid heat on an equal level.
You're cheating. No, okay, good. She read the board. Liquid sink at equal level. Why? Why would they do that? Why aren't lakes just kind of leaning up like this? Why?
Because you left the valve on.
Oh, I left the valve on. Silly me. No, but why? If I leave the valve open, why do they come to the same level and stay there? Why do they stay at the same level? Yes.
I don't really know, but I'm just guessing this time because it would be kind of weird if because it's like stuck. It would be stuck.
Oh, okay. Does anybody have a different guess? Yes. Yes.
They maybe like each other.
They like each other, the water? Oh, the two containers like each other?
I think she knows.
I think she knows, yes.
Air's pushing it.
That's right. And what's it? Which one is it pushing?
It's pushing the one, the two.
Oh, that's right. Air is pushing both of them exactly the same. So they stay the same level. Now, what happens if we push on one more than the other? Let's try that. Well, what's a good way to push on one more than another? Oh, yeah. Yeah. If we push on one more than the other, I'm going to use the dry ice again. I'm going to make pressure in there. I need you to... You're going to put your hand to let... We're going to make more gas from the dry ice, and she's not going to let it out. Put your hand cover it up. Now, it's creating gas, but she's not letting it out, so look what it's doing. It's pushing... More pressure here is pushing the water out to the other container. And if she keeps it going, eventually the gas is going to go to that container. Now let's see what happens when you let go. It's going to come back to its level, but it's going to... Your question?
It's actually kind of an answer.
Okay.
When Sky was putting her hand over it, it actually created kind of condensation.
It created pressure. That's what it created, yes.
since she took her hand off of it, all the gases from that container started going away. But now that you have your hand on it, all the gases are going back into that container.
The gas has nowhere to go.
Yeah,
So it just
what
keeps
is that?
filling up this container and pushing and pushing. The only way it can go is that way.
Yeah,
Then if I
but when
let
you
it
take
come
your
out the
hand
front.
off, all the gases in that container start going away.
But now look what happens. When the pressure's off, it goes right back to the same level, except it's bubbling so much you can't tell. Okay, thank you very much to our volunteer. Good job.